From the definition of the electric potential energy difference, delta U equal to UB minus UA, which is equal to the integral of from A to B minus of integral from A to B over of Q0 E dot dr. Since in this case the test charge is, we can say that the test charge Q0, the amount of test charge Q0 is a constant. So we can take this out of the integration. So we have that this is equal to the minus of Q0 over time A integral from A to B of E minus dr. Okay. Now we will define a new quantity. We call this the electric potential. Electric potential, which is different from electric potential energy. This is just the electric potential. And we define this quantity V, which is equal to the delta U over Q0. Okay, which is equal to the minus of integration from A to B of E dot dr. Okay, this is the definition of electric potential. From this definition, we can see that the electric potential is the ratio of the electric potential energy difference between point A and B divided by the test charge. So it means that if we put a test charge in the region with the electric field, we have the test charge, and this test charge move from point A to B. The difference of the electric potential energy is delta U. Now if we divide the delta U with the amount of the test charge, we have the electric potential. When you look at the mathematical form of the electric potential, you can see that we can calculate the electric potential solely from the electric field. In general, we do not need the test charge because we divided the delta U with the test charge here. So, mean that the electric potential is the property of the source of the electric field. We can say that the electric potential is a property of the source of the electric field. While when we look at the electric potential energy, you can see that the electric potential energy comes from the interaction between the test charge and the source of the field, because you have the product Q0E here. So it means that it's the result of the interaction between Q0 and E. When we want to calculate the electric potential, we have to specify the value of the charge Q0. Okay, we cannot calculate the electric potential energy from the electric field only. So the electric potential energy is the property of the system. You can say that the electric potential energy is the property of the system. Okay, the system here means the test charge and the source of the electric field. But the electric potential, when we calculate the electric potential, you can see that we need only the electric field. So if we know the source of electric field, we can calculate the electric field. We can calculate the potential, electric potential. To be precise, I have to write this as the difference of electric potential. Okay, the difference of electric potential, or electric potential difference. Electric potential difference, which is similar to when we write the electric potential energy difference. Okay. So this is a similarity when we define the electric field, because the electric field is the ratio of the electric force between the source of the electric field and the test charge to the amount of test charge to the test charge. So when we calculate the electric field, we do not need the test charge. It is a property of the source of the electric field only. And when we calculate the potential difference, it is a property of the source of the electric field only too. Okay. So this is a definition of the electric potential. Alright, to be precise, it's the electric potential difference. The unit of the electric potential is the unit of electric potential energy divided by the unit of the charge. So it is the joule per coulomb. Okay. Anyway, we give the special name because this quantity is very important, and we apply this concept many times when we study the electromagnetic theory. So we give the name. We have the name of volt. Okay. On the time that I record this lecture, this is the I'm not sure the time that I record this video is maybe 2 or 3 days before. It's the birthday of Volta, Alexander Volta, which the one that studied the effect of the electrostatic to the animal, and he created the voltaic cell, which is today the prototype of the battery that we use today. So we give the name, the unit of the potential difference in honor to Alexander Volta, and give the name of volt. Okay, so that is the unit of the electric potential. Uh, from this, we have the relation between the energy and the uh, potential difference. Okay. Anyway, sometimes it's more useful to write down the unit of the potential difference this way. We have that the joule per coulomb, the unit of volt is joule per coulomb. But we have that joule is a product of the force. We have the unit of Newton times the length, which is meter, and divided by the coulomb to have the potential energy, potential electric potential, not potential energy, electric potential. Now, if we rearrange this expression, we will have that the volt per meter is equal to the Newton per coulomb. But the Newton per coulomb is the unit of electric field. So it means that we can write down the unit of electric field as a volt per meter. This unit will be very useful, and we will see soon that it gives us some physical picture of the electric potential.